This video will look at finding limits to infinity from a table. To begin, let's start by reviewing our definition of a limit. A limit at f of x becomes arbitrarily close to a unique number L as x approaches c from both sides. The limit of f of x as x approaches c is L. We write it like this. This just means the limit of f of x on the bottom as x approaches c equals L. Now in previous lessons we looked at approaching a number from both the left-hand and right-hand side. For instance, the limit of 3x plus 1 as you approach 2 from the left or 2 from the right. We denote that with the little negative and positives above the 2. But in this video we're going to look as you approach infinities. Now you can't be on either side of an infinity. So let's do this. Let's take the limit of 2x plus 1 over 3x minus 2 as we approach both negative or positive infinity. If we're going to approach negative infinity, we need to pick numbers that are approaching that, which means they're getting smaller and smaller. So in the table, let's pick numbers like negative 10, negative 100, negative 1,000, and so on until we feel comfortable with what the limit is. Alright, substituting these in. 2 times negative 10 is negative 20, plus 1 is going to be negative 19. On the bottom, we'd get negative 32. Now I need a calculator to figure out what the approximation is so I can get an idea where the limit's going. Using the calculator, I get positive 0.5938. Now substituting in the other values, I would get this. Are you comfortable with where it's going? Let's try one more. How about now? Do you see where it's headed? Let's try one more just to be sure. Yep, it's going to 0.66666. That's going to be 2/3. So the limit of 2x plus 1 over 3x minus 2 as x approaches negative infinity is 2/3. But what happens as x approaches positive infinity? Well, now we're going to need to take a table that gets numbers that approach in positive infinity, meaning they get larger and larger. So instead of minuses, let's use positives. So we'll start with 10 and go to 100, 1,000, and so on until we're comfortable with where it's headed. All right, the first one. If we substitute in 10, 2 times 10 is 20, plus 1 is 21, 3 times 10 is 30, minus 2 is 28, and 21 28ths, well, that's actually equal to 0.75. Is it still going the same place? Let's substitute in a couple more. If we substitute in 100, it's about 0.6745. Do we know where it's headed? Let's try another one. How about now? Let's pick one more just to be safe. It's also going to 2/3. So the limit of 2x plus 1 over 3x minus 2 as x approaches positive infinity will also be 2/3. Now it's not always going to be the same way. This just happens to be a rational function of equal degree, which means we take the coefficients of the leading terms, the 2x over 3x, 2/3 tells me the end behavior, which is why the limit as we approach both positive and negative infinity is going to go to 2/3. Well, let's take a look at something that would be a diagonal line, y equals 3x minus 8. Let's take the limit of 3x minus 8 as x approaches both positive and negative infinity. What's this one going to do? Well, as x approaches negative infinity requires negative numbers. So let's pick some numbers that are approaching negative infinity again. Substituting in, 3 times negative 10 minus 8 is going to be negative 38. And then it's going to be negative 308, negative 3008, and negative 30,008. Where's it headed? Well, f of x is also headed to negative infinity, which means it's unbounded. If it's unbounded, the limit does not exist. It's not approaching in a unique number. How about as x approaches positive infinity? Let's pick some numbers again, and let's see what happens. 3 times 10 is 30, minus 8 is 22. And then it goes to 292, 2,992, and so on. What's happening to this side? It's also unbounded, but now it's approaching positive infinity. Because it's unbounded and not approaching a unique number, the limit does not exist as x approaches infinity. Now, if you think about what that graph is, it's a diagonal line. Diagonal lines are always going to approach infinities on the end for f of x, which means the limit will not exist. Now let's take a look at an exponential. Now we're going to take the limit of 3 raised to the x plus 12 minus 2 as x approaches both positive and negative infinity. Why don't you try these two? Make a table, pick some numbers, and see what happens. Pause the video and then resume the video when you're ready to check your answers. I'll give you a moment. All right, hopefully you had a chance to work it. All right, if we substitute in with a calculator, and we're going to need a calculator for many of these, we're going to see that this one pretty quick approaches a unique number. If we plug in the first one, we get 7. But after that, we're going to see that it's -2, -2, and -2. This graph would have a horizontal asymptote as you approach negative infinity on the left of -2, which means the limit of 3 raised to the x plus 12 minus 2 as x approaches negative infinity is going to be -2. But what happens to the limit as we go to positive infinity? Well, let's pick some numbers again. And the first one we see is 1.853 times 10 to the 15th. That is a large number. And if we substitute in 100, it's going to get even larger. Now it's 2.739 times 10 to the 53. This is going unbounded. It's approaching positive infinity for f of x. Which means if we do it again, we're going to get something on the calculator that it can't even handle. It'll say either overload error or something of that nature, which means it's unbounded. Which means the limit of 3 raised to the x plus 12 minus 2 as x approaches infinity does not exist. It's an unbounded value because it's approaching positive infinity. Not a unique number. All right, for the last set of problems, I've got the tables all filled in already. Why don't you take a moment and fill in the limits? All right, the limit as x approaches negative infinity of f of x here. Well, let's look at it. -10 is 1.324. -100 is 0.12. And -1000 has an f of x value of 1.23 times 10 to the -18. Now that's not unbounded. 1.23 times 10 to the -18 has a bunch of zeros in front of it. That's 0.000000000 and so on, 1.23. It's essentially becoming 0. So the limit of f of x as x approaches negative infinity is 0. Now what happens as we go towards positive infinity? It's 12.26, 257 million, and so on. It's unbounded. It's getting bigger and bigger, which means the limit of f of x as x approaches infinity does not exist. Well, let's look at the next one. As we go from -10 to -100 to -1000, f of x is going from -5.26 to -5.25 to -5.2500. Yep, it's going to -5.25. How about as x goes to positive infinity? As we go from 10 to 100 to 1000, we're going from -5.21 to -5.251 to -5.2500. Yep, it's also -5.25 again, or -5.25. Now the last one was actually not going to infinities. I threw something in a little bit different. Let's look at as x goes to 5 from the left to the right, and in general as x approaches 5. All right, as we approach 5 from the left, we can see that it's going from 3.84 to 3.76 to 3.750. It's approaching 3.75. As we come at it from the right-hand side, it looks like it's approaching -3.75. Now, because the left side and the right side do not match, they're not approaching the same unique number. So the limit of f of x as x approaches 5 does not exist. Now, I threw this one in because it's a good example of what I'm going to show next. These are the conditions under which limits do not exist. So when you're working on these, there's 3 things you need to keep in mind. So the limit will not exist as x approaches c if any of the 3 conditions are not being met. Number 1, if f of x does not approach the same unique number from both sides, then the limit does not exist. It has to approach the same number from both sides. Condition 2, if it's either increasing or decreasing without bounds. If it's headed towards either positive or negative infinity for f of x. Lastly, if it oscillates between 2 values. Now this one's a little tougher to understand. If f of x oscillates between 2 fixed values as x approaches c. Well, the easiest way to think about this one is like a trig graph. If you think of a sine graph, it'll help you to visualize it pretty quick. Here I've got a sine graph for you. What happens as x approaches infinity? As x approaches positive infinity, well, this graph is bounded. It's bouncing between its maximum and its min. It's going as high as 1 and as low as -1. So which one is it actually headed to? Is it headed to the positive one or the negative one? And that's why the limit doesn't exist. It's going between 2 numbers. So if it's oscillating between 2 values, that's an example where the limit does not exist. So these are the 3 conditions where you could say the limit does not exist. All right, thank you for watching.